Climate change is continuously influencing the world's ecosystems and environments. This is especially true for the oceans, where rapid and dramatic climate change has been reported in the circumpolar high Arctic for decades, and it is widely anticipated that impacts on marine mammals will be mediated by the rapid change in environmental variables here. Each year we are seeing the sea ice cover melting faster, leading to a shift in temporal and spatial prey distribution and abundance. The consequence of these changes is having profound effects on the behavior and fate of the species who are bound to the Arctic sea ice. The bowhead whale is one such of these species. Global climate change of the Anthropocene is not the only epoch that these long-lived whales have had to alter their behavior for. Ancient DNA studies indicate that bowhead whale lineages survived late Pleistocene climatic changes and habitat shifts. However, the speed of the change seen in today's climate in the Arctic is worryingly fast, prompting to question whether bowhead whales can survive such dramatic changes. The bowhead whale is the only whale endemic to the Arctic. They have a highly adapted to ice-covered seas, maneuvering through extensive areas of solid ice cover. Despite the overall mixed impacts of climate change in bowhead whale populations, one author, Kovacs and Idison, reported an increase in populations in recent years in the North Atlantic Circle and surrounding South Seas. In addition, they note that body condition has increased in several populations, which is a positive indication of healthy animals, indicating a sufficient food supply. They hypothesize that this increase is related to their increased feeding opportunities. The recent reduction of sea ice has opened access to coastal waters and increased open ocean area, increasing the habitat range of the species. Another result of more open waters is increased net primary productivity, due to more light entering the ocean for photosynthesis and a longer growing season. This changes might translate into enhanced secondary production, initiating higher krill concentrations and broadening the feeding opportunities for the bowheads. Having said this, the improvements reported here are only likely temporary due to the movement of temperate zooplankton northwards. Bowhead whales migrate annually to feast upon the rich feeding grounds of the polar regions. With rapidly changing temperatures, this might impact and alter their ability to navigate through difficult sea environments as the temperature rises and the ice disappears. A study focusing on bowhead whales in the Western Arctic illustrated a change in migratory patterns due to the increasing of temperatures within the Arctic Circle. In addition to the ice conditions, the feeding habitat of bowhead whales is largely defined by water depth and oceanography. A study exemplified that while bowhead whales are probably limited by their diving depth, their affinity for shelf waters is likely more related to the availability of better feeding conditions than their ability to dive. Zooplankton within shelf waters are further aggregated by fronts and stratified layers, which, along with upwelling and advection, create situations where zooplankton aggregate in sufficient densities. The current mechanisms that deliver and aggregate zooplankton are expected to continue. However, it is uncertain if these oceanic systems will remain and how long into the future they can last. Although recent research highlights the positive effects of climatic shifts in the Arctic region, the fate of the bowhead whale is difficult to gauge because the effects of reduced sea ice and warming waters on polar marine food webs are uncertain. It is believed that the receding sea ice will bring a multitude of negative impacts for this Arctic species. The bowheads are dependent on the ice protection from killer whales, where they can seek sanctuary under the ice from these predators using their hard rostrum to punch holes in the ice to breathe. In the open water, the large, slow-swimming whales are under particular threat, potentially struggling to escape. Another area of concern to this species is that as the Arctic has less sea ice cover for longer periods during the year, it opens the Arctic up for commercial shipping and human use. The industrialization of Arctic waters would increase mortality of these whales from ship strikes, as well as causing significant disturbance to their behavior. The warming of the oceans will drive species north in search of cooler, more productive waters. This will bring bowhead whales in direct competition with other baleen species, such as humpbacks. The warmer waters will also be favoured by smaller southern zooplankton, which are less calorific and render the bowhead at a disadvantage in the future. Further negatives include baleen whales' breeding patterns, which may be timed to coincide with maximum abundance of suitable prey, either for the lactating mother or the calf at weaning. Therefore, any changes in the environmental condition that determine prey abundance may cause a mismatch in synchrony between predator and prey, either in time or location. This impact has on female whales not being able to gain enough body fat to reproduce, reducing breeding success of the species. Finally, climatic change will also affect external and internal physiology of these animals. For instance, disease transmission and pathogen development will increase, resulting in these whales having an increased host susceptibility. Higher temperatures may stress organisms, increasing their probability of contracting diseases, especially if they are at the upper end of their thermal tolerance. Climate change is expected to affect the range and migratory patterns of many marine animals, which in turn could lead to a spread of viruses and the introduction of novel pathogens for which bowheads do not have established immune responses. The external issues that may arise include whales succumbing to sunburn. This has already been observed in blue whales, and the bowhead whale may also be intolerant to intense solar radiation. The bowhead whales have extensive blubber layers, and an increased water temperature partnered with declining ice and intensified solar radiation will have a profound negative effect upon the epidermal surface of these polar adapted whales, leading to heat stress. The recent climatic changes in the Arctic are playing a significant role for the bowhead whales. This species is making the most of an increased ocean productivity, but we must ask, how long can this be sustained? As the ice continues to recede faster and warm water starts to penetrate the Arctic, will the bowhead whale be able to cope with increased competition as well as profound human conflict? We just don't know yet. Although it is very likely that the plethora of new challenges initiated by changing the Arctic region will occur at a pace and multitude too fast for the whales to adapt to.